Hello, this is the third video of the first Sequences and Series on Summing series for OCR Pure Core Further Mathematics, and it looks at the standard formula for the sum to n terms of r squared and r cubed. In previous videos we noted that sigma 1 from r equals 1 to n equaled n, and that if we summed r, then we had half of n plus 1. Here is the standard formula for the sum to n terms of r squared, and it is n times n plus 1 times 2n plus 1 all over 6. There are several different proofs of this result, and you can see the notes and examples in Integral or your textbook. You can also prove this using mathematical induction, and you should note that proof by induction is covered in other video series. So we can use this formula as a standard result. So in this example here, we note that n equals 20. And so, using the standard result, between r equals 1 and 20, the sum of r squared will be 20. 20 plus 1. And 2 times 20, or 40, plus 1. All over 6. Which, if you use your calculators, will give you 2,870. So remember that in order to be able to use that standard formula, you have to be able to identify what n is. Turning our attention now to finding a standard formula for the sum to n terms of r cubed, let's look at this animation. Here we have 1 cubed plus 2 cubed up to plus 5 cubed. But let's look at those cubes numbers in a slightly different way. Well, 1 cubed, we can see it's the same as 1 squared. 2 cubed, if we halve one of those sides, looks like that, 3 cubed. And you can see the pattern extending. Thus you can see that the sum of the cube numbers is related to the sum of r. So it can be shown that the sum from r equals 1 to n of r cubed equals the sum from 1 to n of r squared, and hence it follows that the standard formula for sum to n terms of r cubed is n squared, n plus 1 squared over 4. Remembering that the sum to r equaled n plus 1 over 2. For a proof of this, see the notes and examples in Integral or your textbook. You can also prove this using mathematical induction. We can use this standard result in questions. As before, the key is to identify n. Here n equals 10. So substituting that in, we would have 10 squared, 10 plus 1 squared, all over 4. 100 times 121, all over 4. Which, if you use your calculator, comes out at 3,025. Remembering again that I looked carefully to check that r was starting at 1 and that n was 10. In the next video, we will use the standard formula for r squared and r cubed to find combined sums.